student. Welcome to the chemistry class. Today I am going to start structure of an atom. So as we know that
atoms are the building blocks of all material.
Atom, which is the fundamental particle. In Greek, atom means uncuttable or indivisible. So it was supported by John Dalton, who proposed Dalton's atomic theory in 1808. According to Dalton, atom is the smallest particle which is indivisible. So this theory he able to explain successfully many of laws of chemical combinations. Then he concluded that an atom can neither be created nor be destroyed. So we can't able to create an atom also, even we can't able to destroy it also, but we can change from one form to another form. The idea of indivisible was disproved by the discovery of radioactivity. According to radioactivity, an atom is composed of three fundamental particles, namely electron, proton and neutron. These are also called subatomic particles. Then the discovery of these electron, proton and neutron opened the way for further research on internal structure of an atom, which explains the diversity of chemistry and the wide range of chemical reactions. So later, actually in this chapter, we are going to discuss on different atomic models as well as quantization of energy. Next, the discovery of an electron. Okay, so an electron was discovered by J.J. Thomson, and electron was found to be first fundamental particle. J.J. Thomson in 1897 he discovered electron. Actually he was utilized Faraday's electrical discharge in partially evacuated tube, which are called as cathode ray tube. It is a device, cathode ray tube, it's a device made up of cylindrical hard glass tube fitted with two metallic electrodes which are connected to oppositely charged poles of battery. Okay, it's a simple device. It's a cylindrical glass tube. Okay, well, then what was the observation? What they were observed? When gas taken in the tube was subjected to very low pressure by vacuum pump, maintained by vacuum pump, and applied a very high voltage around 10,000 volt, the current flows through the circuit. Okay, and also they observed that there is a stream of particles moving in the tube from cathode to anode. These stream of particles were known as cathode rays. So two things they were observed here. When subjected the gas to a very low pressure and high voltage around 10,000 volt, they found that current flows through the circuit, and also they observed a stream of particles moving from cathode to anode. Because they are moving from cathode to anode, so that these are called cathode rays. They named as cathode rays because they are liberating near the cathode and travels towards the anode, so that these are called cathode rays. What are cathode rays, they will ask. Okay, so important. So next, why they are maintaining very low pressure in the vacuum tube? So actually in low pressure, the space between the atoms is very large. So that the atoms can get accelerate and they can strike each other, and so that they can eject an electron very easily. So at low pressure, the space between the atom is very large, so that they can accelerate at a very high voltage 10,000 volts and strike each other. They can eject an electron very easily, so that they are maintaining low pressure. Then how to confirm the cathode rays are present? Actually in visible light they are invisible. Okay, in daylight they are invisible. So how to confirm it? By making a hole in the anode, the cathode rays striking the phosphorescent material we are using here zinc sulfide, phosphorescent material zinc sulfide we are using here, which is coating on the tube behind the anode. When they hit the surface of the tube, they are going to form bright spot. Confirms the presence of cathode rays. Next, characteristics of cathode rays. Actually, cathode rays they are going to produce near the cathode. They used to move towards anode, so that always the cathode rays moved from cathode to anode. And these rays are absorbed with the help of fluorescent or phosphorescent material, as these are not visible. Actually, as it is, if you see in the visible light, they are not visible. Only when they falls on the fluorescent or phosphorescent material, we can observe a bright spot. They are going to form bright spot. Thereby we can identify the presence of cathode rays. Next, these rays travel in a straight line, because these cathode rays are also considered as electromagnetic rays, and so that they are traveling in a straight line in absence of electric and magnetic field. Only in absence of electric and magnetic field they used to travel in a straight line, but in presence of electric and magnetic field they deviate towards positively charged plate. And it is confirmed which one they are traveling in a straight line. That was confirmed by keeping a small object along their path. They are going to form a shadow opposite to the cathode. They are going to form shadow opposite side of the cathode. Okay, when we place a small object between cathode and anode, okay, these rays travel in a straight line in the absence of electric and magnetic field. It is confirmed by formation of shadow on the opposite side of cathode when a small object is placed between cathode and anode. Next, they rotate the little paddle wheel placed in their path. They can able to rotate the paddle wheel when we place along their path. This shows that cathode rays contain material particles having both mass and velocity. Only we can expect displacement when a particle hit on the other particle. So, to displace this paddle wheel wings, it should be a particle. The cathode ray particle should be a particle. Then only it can able to rotate the wheel. So it clearly confirms that it is having both mass and velocity. Okay. Next, these rays were consists of electrons produced by the ionization of gaseous atom by the discharge tube, and they were responsible for the flow of current. These were the responsible for the flow of current. Okay, when electric and magnetic field is applied, they deflect towards positively charged plate. Because these are negatively charged particle, and so that they used to deviate towards positively charged plate. So from all these statement, we can conclude that cathode rays consists of negatively charged particles called electrons. And also, the property of cathode rays does not depend on nature of gas which is taken in the tube, and also electrode material. For different gases, if we conduct same experiment with the various gases, they observed same result. So this concludes that electrons are the basic constituent of all the atoms. So this concludes that electrons are the basic constituent of all the atoms. So it clearly tells that when they conducted experiment with various gases, they observed the same result. So this concludes that electrons are the basic constituent of all the atoms.
The discovery of proton and the discovery of neutron I will discuss in the next session. Thank you.